Hello, Steve, Quinn, and Samantha. I got to thinking it seems like we're having trouble getting together, so I'm going to make a video. So you guys know, and then if you have any questions at all, message me back. I can't make 4 o'clock today. I'm so sorry. I already had a doctor's appointment scheduled for my son. So let's do it this way. If you have questions, you can email me, and we could always meet tomorrow because, I know nobody wants to meet at 7 o'clock at night. So, guys, I'm panning through the lab book. In the lab book review, I'm not going to sit and read the answers again because you could do that in the lab book review they did previously. But I'm scanning through everything that you need to know for Exam 1. Exam 1 is this coming Monday. Okay, so this coming Monday is Monday, September 21st. And all of this up to 42 is fair game for the exam. There'll be 25 stations. You'll come in at 11:30. I'll have it set up for you. There'll be 2 questions a station. Now, the only difference from last year is I will not let you go back to stations because we're not supposed to cross-contaminate like that. I'm going to have you go through, give you 3 minutes at a station, and then you move on to the next one. Okay, so lab exam this coming Monday, September 21st. So go through all these answers. I already did reviews for all the lab book, all the way from 1 to 42. Okay, so the next thing that I'm going to do is open up the tissue slides. And last week we went through all the squamous. So there is stratified, I'm missing an R in there, squamous, multiple layers of egg-shaped cells, simple squamous lining and capillary, 1 layer of egg-shaped cells, pseudostratified ciliated columnar is found in the trachea. You've got the cilia at the top, the oval nuclei, and some of them even look roundish, that are at all different heights, but those cells all touch the same basement membrane or basal layer. Okay, so always look for the cilia. A goblet cell is going to be a unicellular gland that secretes mucus to the surface. And simple columnar, which is found in the GI tract. The difference between simple columnar and pseudostratified is the nuclei are all at one height. They are oval shaped as opposed to varying heights that we see in pseudostratified. Here's an example of another goblet cell. Simple cuboidal and a tubule. The cells are as high as they are wide with round nuclei. Now, connective tissues, I believe we did last week as well, and you've already done. Adipose has a soap bubble appearance. Dense regular connective tissue is found between the skeletal muscle. It is thick collagenous fibers going in one direction. That's a closer magnification of dense regular connective tissue as a tendon. Hyaline cartilage does not have obvious fibers in it. It does have fibers in it, but they're not stained. The cells are interspersed as opposed to elastic cartilage. I'm going to get a picture of elastic cartilage for you. I like this one. This was fairly close to this one. This one's close to what we look at in the lab. The cells are closer together in elastic cartilage, and you could see the fibers. There's elastic fibers spread throughout that matrix. See it a little bit better on the actual slide. So in here you can see the dark staining elastic fibers. You can see them really good right in there. And this should all be reviewed from last week. No bone tissue that's easy to identify. Know the different parts. And then what we looked at this week was nerve. Now, definitely know a neuron. When we're looking at the nerve cell slide, you should be able to see the cell body. If we're looking at loose areolar, it can actually look pretty similar. So the main difference that you could tell between them is looking for that cell body that has the dendrites and the axon coming off of it. Now, with dendrites, it's hard to differentiate. I won't make you tell the difference on the slides. But with the dendrites, you can see the singular dendrites here. The axon is always thicker. So you can see it well on this picture, not as well on the slides in lab. Okay, so nerve tissue versus loose areolar, know the difference. The difference is that cell body that I'm pointing to. It's going to take a second for the PowerPoint to kick back in. Okay, and then we looked at muscle tissue. So we've got the three types: skeletal, smooth, and cardiac. Okay, skeletal, let me see if I could blow this up for you. Yes, you could see it actually better if you blow it up, and you could probably see it better on your own computer. Skeletal has long skeletal fibers and multiple nuclei in that fiber. And then you can see striations across here. I'm going to clear the drawing tool. So if you look at it closer, or if you pull this up on your own computer, the key for skeletal muscle is the striations. So when you walk up to the scope in person and you do the fine focus, you should see the light and dark striations alternating throughout that muscle fiber. Smooth muscle does not have striations. Disregard these lines. These are actually, I took pictures of the TV screen. Sorry, my dog's barking at somebody. In lab. That should not be there. Okay, smooth muscle. Hey, knock it off. Smooth muscle has long, pointy muscle cells. I think the mailman's here, so she's like acted like a tough girl. Okay, so long, smooth muscle cells with an oval nucleus in it. And you will not see striations. Like I said, disregard these lines here. You will not see that in smooth muscle. The other thing is all of them... I'm so sorry. Hey, come here. Bootsy, come here. Hey, yes, I know he's here. I'm going to pause it for a second. I'll be right back. Oh, now she's done, I think. Erector pili is going nuts on my dog's back right now, by the way. Okay, so you'll see these smooth muscle cells pretty much all going in the same direction. Okay. And you look for those long oval nuclei. They look similar to dense regular connective tissue, but you're going to see more nuclei in them, and the nuclei will pretty much all be going in the same direction. And this is found in the GI tract, for example. The last one is cardiac. Now, some additional things that we need to review on cardiac. They are Y-shaped cells. And you could see one here. Okay. And they have what are called intercalated discs. This is new. Review this. Well, it's not new, but I point this out. Intercalated discs are the connection between one cell and the next, and it allows the signal to flow from one to the next. Now, we don't have a great slide for intercalated discs, so most likely I would show you a picture like this one. Skin. Okay, review all the parts of this skin. You can see here epidermis, which is going to be stratified squamous, hypodermis, which is primarily adipose in it. The dermis is where we have all the glands and the structures that I have you describe. We have the hair follicle and root. Attached to it is a sebaceous oil gland. We also have attached to the hair follicle erector pili, which was making my dog's hair stick up straight when she was just barking at the mailman. Okay. There's also sensory receptors. Close to the top, to where the epidermis is the Meissner's corpuscle. Deep is Pacinian. So this is Pacinian, this is Meissner. And I do a very thorough review of this in the lecture or the lab video review. This is a sweat gland, and this secretes sweat to the surface. Okay, I believe I already said sebaceous oil glands are attached to the hair follicles. Okay, so make sure you review those structures. Dense irregular connective tissue is what fills the bulk of the dermis, which is this middle portion here. Okay, it's as simple as that, guys, what we reviewed. You will have to take your lab quiz. You can do that while you take your lecture exam on Monday. So please review this. If you have any questions, let me know. And I thought this would be the best way to do it since we're having a little difficulty connecting with each other. If you feel that you need to meet and review online, absolutely let me know and I can do that for you. Okay, so get back and let me know if this works for you, if you have questions and if you want to meet. Thank you. Bye.